Okay, initial power amp of the dual Showman amp. This is my brother's amp. Hasn't been ran in a while. Last time he had it going, he said it had some hum to it. So we're gonna take it apart, take a look at it. I think it's a 64 or 65 Showman. We're gonna bring it up slow on the Variac and see what it's doing. Okay, we're sitting at 55 volts. Jewel light came on. Got volume at 3. Let's put treble 5, middle at 5. Let's put bass at about 4. And turn the speed intensity off. We're gonna try this vibrato channel first. And on the current limiter, bulb is not lighting up. So let's go ahead and turn it up a bit more. Okay, we're at 90 volts. Nothing. We got a standby on. I'll go ahead and flip standby off because right now nothing's going on with that bulb. Stable. Go ahead and turn it to 120. Getting just a little bit of glow, red glow, which we would expect on the filament of this bulb. Just a little bit of red glow on it. Not too much. We're 120 volts. Jewel light's nice and strong. I don't hear anything. Strum the guitar, nothing. I think it was on standby. It seems to be on. There it is. Now I heard it. Got a glow. Oh, I think one of the power tubes might have been a little loose. Okay. See if we got sound now. Oh yeah, this thing has a master volume on it too. The master's all the way at 1. That's the problem. The master was all the way down. It's not supposed to have a master, but somebody put one in there. So apparently the master does work on the vibrato channel. Sounds pretty quiet though for the master being at 5 and the regular volume being at 3. Let's turn the master all the way up. Still pretty quiet. Hear hum. Close. Let's hear this. And a little storm going on in there. So let's power it down. Doesn't sound good. Got the dual Showman on the bench now. So a view of the back. 2.5 amp fuse. I've got just a little shorting jack in there in the vibrato pedal. 2 amp chart. I'll take the back off and get a better look at that. Check the fuse. It's a bus fuse. It is a 10 amp fuse, 2.5 amp, 10 amp, no good. No good. So I don't have any 2.5s, but I've got some 2s at 250, so just added protection. It should be fine. I don't think it's going to draw that much. We'll check it on the current limiter and see what's drawn. Quick flyby on the front panel of this. Fender Musical Instruments. So it's probably a CBS amp. We'll check the dates on the transformers, because it doesn't say electric instruments, but I've seen this amp before. I thought it was a 65 or 64. Dual Showman, speed, intensity, volume, treble, middle, and bass. Bright switch. Ooh, I usually don't like it on. Maybe he does. Let's see, volume, treble, bass, and a master volume, and they put it in the first input, which is usually what I use, but then again you got both inputs on here, so I would usually use the vibrato channel anyway. I wonder if they changed the input number 2 resistors or what it's set up as, but I do know the master works on the vibrato channel because I tested it before it started making much noise and I turned it off. Eventually we'll test it. I believe it also probably works on this channel, but perhaps not. Perhaps it's wired only for that channel. It should be for both though. We'll see. We might even put a little sticker right here that says master. These knobs on the front look kind of like replacements. Definitely got some old rust patina on these guys. And then these screws are replaced. Took the screws out. Pull this back panel off. Made out of real plywood. Could use a little bit of glue right there and glue that one down. A little glue there. Well, not too bad. A couple edges we can glue back down. Cobwebs. And we got 4 606 GCs. 12 AT7, 12 AX7, and 270 25s. Fender Musical Instruments. And I don't see any letters there. Then these have been replaced with Sovtex. And we'll take a look at these. Well, that transformer looks cocked. It doesn't feel loose, but like it got dropped or bent or something. 2 huge transformers in here. Power transformer, and output. And they're both kind of on the same side. Makes this amp real heavy. We'll have to look in the doghouse and see if these capacitors have ever been changed. I think these tubes all are too. I think he got this whole thing retubed at one point in time. Alright, we'll take a little bit of this Weldwood contact cement. Kind of fix all these little edges. They're sticking up. Put a little on there on both sides. Let it get tacky. Stick it right down. Works great. All glued up. Let that dry a few minutes. I'll just stick all those edges down. Now we have the chassis out of the cabinet. Some gross little bug droppage or something. A little more loose Tolex, which we'll glue back down. And that one too, to make it easier to get in and out. Surprised it didn't get snagged on that. Actually came out pretty easy, but yeah, we'll glue that down for sure. Okay, better view. AB763, it's what you want to see. And a little black line for export only. So they black line through the export only. Interesting. Manufactured under patent 2817708, made in USA. Fender Musical Instruments, Santa Ana, California. Cool. That grill cloth has been replaced also. Might need to be done again. It's actually turned the wrong way, which isn't the end of the world, but it's not quite right. Alright, here we are inside the amp, and it mostly has the blue Mallories, which is good. People like those, but I'm pretty sure we're gonna want to change all these out. These are probably, I guess they're original, if not they're very old bypass caps. So double here, then we got, I guess, a single here. I know that one's old Mallory. Those electrolytics ought to get changed. Funny, the Roach has masking tape on it too. Somebody must have been messing with it at some point. This is some handiwork of mine. Very early on in my stage of working on amps, and I really didn't know what I was doing. And I put a couple wire nuts in and put a 3 grounded 3-prong cord in, and I cut the death cap out. But we're gonna redo this properly, and we'll probably put in a ground right to chassis instead of using this bolt. This is the heater wire, which was completely burnt up when I did work on this before. So we trimmed it off and we put a new wire in to here, but I crimped it instead of soldering, because actually back then I didn't know how to solder. So we're gonna redo that as well. And then we're gonna take a good look at the center taps here that are grounded to here, and we'll probably go ahead and just put a chassis ground in like they used to, because I don't know, seems like a better idea. This one too, this looks it's not loose, but we might get a little solder on that too, make sure that's getting a good ground. This spray Gatum looks like it was changed out maybe in the early 80s in the bias. We've got over here on the power tubes, we've got the screen grid resistors. Boy, that sucker looks like it's been hot and burnt up. We're gonna have to change them out. Probably the grid stoppers in there. Yeah, this one don't look so good either. They're at the end of their lifespan, and there's a very good, oh, that one too looks burnt. Very good chance those are what's making all the crackling and grumbling noises on this thing. But we also suspect possibly these 100K plate resistors through here, basically all through the preamp. They don't look bad, but I've had experience from the past where they just, you start messing with them and they just actually fall apart. They get so much heat too, or heat or electricity, and they just don't seem to last. But we're definitely gonna change some of these caps. This guy, who knows what the heck that is? That doesn't look Fender. I've not seen that before. If it's not a problem, we'll probably leave it, but I don't know what the heck that tropical fish looking thing is. Then the back of the pots looks like they've got some grounding wires. Somebody added, they added the master volume. Comes in, it ties in. Probably somewhere here around the phase inverter. These big old orange drops, they are probably replacements. They probably were not original, but they could be. They're 0.1s at 600 volts DC. Big old orange drops. Let's see, W9. I don't know what that code means. No date stamped in here, and then their code on the transformer. Looks like a 67 on that too, and a 67 there, so maybe this is 67, but we will look at the transformer date codes real close. Alrighty, here we are top side. We got a bunch of this white rust. We'll try and take some alcohol wipes and wipe that off. 4 preamp tubes. Fender 606 is Schumacher. 24th week of 7, which is 67. A bunch of those caps inside said 67, so this is a 67. So this is a CPS. For some reason I thought it was a 64 before, but I think I was wrong. This is 606, 25th week of 67. So yeah, this is a 1967. And then this little guy, 606, 7, 26 week of 67. So yeah, this is 67 unit. Okay. And we'll get underneath that doghouse and see what we got in there in a minute. Note here, all these bins, this is somebody taking a screwdriver and trying to get this out when they were working on it, because the Tolex inside here was all stuck, and now we re-glued it back down, but somebody more than once had trouble getting it out. And I remember seeing that last time I had this amp open 5 or 10 years ago, and I remember having a hard time getting out, but I also remember somebody else had already bent it all up previously. The great reveal, what's under the doghouse? Oh, it's the originals. Yeah, that could be a source of the noise. Look at that guy. Look at that guy. Exploding his guts right on out. A little bit of light on that. Okay, that guy's bubbling. That guy's got a bubble. Gut explosion. Bubble. And we can't see the other side of that one. But yeah, they all gotta go. They gotta go. And then these resistors need to be updated also. And another date code in there. We got, let's get that light over there. B3467. Everything keeps going back to 67. What do these say? Another 29th week of 67. Yeah, all the date codes are 67. This is a 67 amp for sure. And these got to go. Interesting, some tech in the past wrote down the voltages at each one of these nodes. 400, 440, 445, 470, ground. And on the other side, they were all grounds, so I guess those are G's. And then this one looks like 295 or something like that. Interesting. And then this leg of the transformer is bent up, so at some point in time this thing took a bit of a drop or something and bent that up a little bit. Not the end of the world, it's just a mounting leg. Probably just leave it the way it is. It's probably been that way a long time. Actually, this one's the same way. It's bent up a little bit too, and has a replacement screw on that side. So yeah, this thing took a drop at some point. Moved those. This one doesn't seem like, actually, you know what? Chassis is bowed. Probably can't see that. The chassis got a little bit of a bow right here. This whole thing got dropped at some point, no doubt about it. No doubt. So this amp has certainly gotten overheated in the past, and this wire was all burned up. If you look close down in there, that's the bias circuit's ground, and it's got like a dielectric grease or something. I bet that came loose and the bias went nuts and the tubes overheated. These guys over here got cooked. This wire got cooked, and it was probably because that came loose, and all because this thing's been dropped before and the chassis kind of malformed here. And you got a ground point on every part of this transformer, all 4 lugs. I don't trust any of them. We're gonna have to do chassis grounds on each one of these. So we definitely will have a good ground for the bias, a good ground for the main chassis ground. I don't trust that. Good ground for the center taps for the high voltage and the 6-volt winding. And I'm not positive what that ground is, but it's going to be a good one too. We're going to redo all those. Then we'll redo this power and bring it in, do Uncle Doug style, and bring the black wire all the way to the switch first, then to the fuse, then through the transformer, and then back out the white. We'll completely bypass this ground switch, and we'll turn it into a off-on negative feedback loop, and that'll bring this amp to life a little bit at lower volumes. Also, after looking at the caps, this thing needs all new caps. So we're going to redo all the electrolytics, redo the resistors in the power supply and under the doghouse in the power supply. Redo, this is from the 70s or 80s, this Sprague. It's a good cap, but we're going to put a new one in there too, and a new resistor in there too while we're at it, just to make it up to date and reliable. And then we'll have to try and bias the amp and see what we get. And realize this little tropical fish is part of the tremolo circuit, which somebody definitely worked on before. That wasn't stock, and neither was this masking tape. But last time I knew, the tremolo worked good in this amp, so we may just leave that alone if it still is working good. And the preamp tube sockets all look fine, dandy. Here, green wiring looks all fine. So we'll also clean the pots and clean the contacts on the inputs, and the self-grounding jack back here too. We'll clean that on the speaker out and make sure everything's tip-top, and hopefully there's no DC leaking out of any of these blue sausages. I like to keep them in there for that vintage mojo, but if they don't sound right or the DC is leaking, they'll get changed too. Here we go. Got all our new F&T caps in. Got them lined up. Positive, 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 negative. Original caps are still in. Positives on that end for that one. So this one's negative. Positive, 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 positive. Let's see. 320s and then 270 at 350 volts DC. We went ahead and went with 100 volts because that's what was available at 350. Should be just fine. So on this eyelet board, this side, the old tails didn't want to pull out easy, so I went ahead and just made loops. I'll tie onto them. It'll be fine. Sometimes they run the leads extra long and time and other stuff. New F&T filter caps installed. Done a little bit of marine grade silicone sealant from 3M, and all new power resistors. A couple of them down in there. Should be good for a long time now. Let's put the doghouse back on one. Next, we're going to replace this 1970s, maybe early 80s Sprague Atom 80 at 150 with a 100 by 100, and then we'll replace that bias resistor in there too with a metal resistor. Bias supply caps and resistor installed. Next, we're probably going to tackle these screen grid and the resistors in there. They just get so hot. They look just baked. Time to go. Another thing we noticed is in the power section, these filament wires are supposed to go from pin 7 to pin 7, pin 2 to pin 2, but they're twisted and they're the same color, and they don't. They alternate, and that can induce hum, so we're going to swap those properly too in there, so they're all pin 7 to pin 7, pin 2 to pin 2. Reduce hum. Okay, quick flyover. We got new power cord, new bias cap and resistor, new grid, new power tube resistors. We got a couple new resistors here and there, and only the ones that were out of spec. And we got new bypass caps in, and in the doghouse we got all new filter caps. So major overhaul this amp. Oh, and then we fixed a couple of these heater wires were twisted the wrong way. Instead of going from pin 7 to pin 7, they were swapping back and forth. So we fixed that too. Have to fire her up and see what she does. Bringing the amp up on power on the Variac, the current limiter for the first time. About 50 volts. 54 volts in. Getting 61 volts plate current. And then plate. Okay, 120 volts going in. We got standby on still. Plate voltage has gone down to basically less than a volt. Seems kind of odd. Standby is still on, so maybe that's the way it's supposed to be. And then we got nothing on our voltage drop still, which is the center tap of the output transformer to the plate. So let's go ahead and flip standby on. See what happens. Okay, we heard the speaker kick in. Went to 520 volts, then dropped down to 433. Okay. Voltage drop. Reading -1. We might need to adjust the meter. Turn the meter off. Adjust it to 2000. Turn the meter back on. Interesting. We're stabilizing around 436 volts. That's pretty good. Let's go ahead and turn this back on and flip it again. Okay, -0.72. That's probably more like what we're looking for. Flip this one off. It's a 20. Flip it back on. Okay, pretty good balance. And you probably divide by 2 because we got 4 power tubes. So we're probably looking at, anyway, we'll figure out in the math in a minute. Stabilizing at 435 plate volts. So far, so good. And the volume is turned down on everything. No smoke, no light, current draw, 1/2 amp. That's good. I think everything's good. Strong jewel light. Okay, our plate dissipation ended up being 4.13 and 3.26. And I knew it was probably going to be low because our voltage drop was real low to start with. So we did a predictive measurement because we want to get around 13.8, which is 60% of 23 max plate dissipation for 5881s. So we did voltage drop divided by plate dissipation. We had in set A 0.69 divided by 4.13 over 13.8 is what we want, and we want to solve for x. So cross multiply and divide. We're looking for 2.305 voltage drop. We'll set it there and then recalculate plate dissipation and see what we get. See if we get around 13.8. Okay, we maxed out the bias voltage pot there, and we brought the plate volts down to 399, which is actually good because the max plate volts for 5881s is 400. But we couldn't get to what we wanted, which was 2.3. We're only at 1.5 and 1.4. I think we could change out that resistor and make it more, but I'm not sure. And again, this amp wasn't designed for 5881s. It was designed for 6L6s. So let's calculate and see what this gets us. Okay, we'll do a quick little sound demo. I've got this Showman hooked up with a Fender reverb tank too, so we can get the authentic Fender tones. Also got the vibrato Houston, your imp is back from the dead. That tremolo was ticking something fierce, so I went ahead and did the ticking tremolo mod. We added in here this guy, 0.01 cap from the 10 meg resistor of the LDR to the ground side of the LDR, and that knocked that ticking tremolo right out, and it sounds great. Okay, in order to bias this thing, we had to take out the 27K resistor and put in a 15K, otherwise the bias pot was maxed out. And for our current wall voltages, non-1967 wall voltages, it was not biasing correctly. Now it's biased correctly. About 50% plate dissipation roughly. So a low end bias, but it sounds real good, so we're gonna leave it there. One last finishing touch under the doghouse. Went ahead and put the date on there and my initials, 7/8 of 23. It's been recapped. One last flyover. See everything we did. Can't get this tremolo to quit ticking. So when it goes in the, it's not so bad with just sitting on the bench. When it goes in the case, it gets all dark. It just starts ticking away. It's been worked on before. Somebody had maybe replaced something in there, split it open, and then put tape on it. And they also replaced this 0.02 with this fish, tropical fish style 0.02. I don't know. And I tried putting a 0.01 cap from the 10 meg over to ground, over here to ground, and that didn't get rid of the ticking. So I think we're gonna try and replace these caps, maybe order a new LDR and see what we got. Okay, to get this tremolo to stop ticking, we had to do a bunch of stuff. We had to put this big old 0.2 cap in here, then a 0.01 in here from the 10 meg resistor to ground. This just goes across the 10 meg resistor. And then we also, down here on this left leg of the LDR, we had to put a 470 ohm resistor. This is just the left leg. The right leg is still going to this solder joint here. Just hard to see with the camera angle. Those aren't touching. We might separate them a little more, but they're not. Now you should be able to see. They're totally separate. Focus, totally separate. And it seems like we've stomped out the tick, and this tremolo moves around leads, didn't work. We also took ground from the 100K resistor off the speed pot. We ran that over here, the 2.7K ground point over here from the oscillator tube, from the cathode of the oscillator tube, to help isolate the ground. That helped some. Just starting with the 0.01 in there helped some, but we really didn't kill the tick until we added this and this, and then we killed the tick. Now it took away maybe a little bit of the intensity and gain out of the circuit, but the tick's gone. The tick was unbearable. It's funny is the tick was okay until you would put it in the amp and make it darker in here, and then that resistor would get, I guess, anyway, it would work better. That photo sensor would work better, and then it would add a lot of tick. So I'd put a piece of cardboard over here to test it, and as soon as I put the cardboard on, tick would come back. Take the cardboard off, tick would be gone. Crazy. Okay, before we put it up, one last fly over this amp. All new plate resistors, 100Ks, because they were noisy. All new cathode bypass, coupling caps, electrolytics. Let's see, everything in the tremolo, new resistors, new caps, fixed the LDR, put in some extra capacitors and a resistor over here. You get the ticking out of there, 470K, no, just 470 ohm resistor, 0.01 cap there, and a 0.2 cap there. Let's see, fixed these were in there already, but their leads were all a mess. Had to put in a couple new resistors here that were out of spec resistor. These resistors were out of spec and making the output tubes not balance. Let's see, add a resistor to the adjustment pot here for the bias, so that we could actually bias these tubes, because these are 5881s in here. They're supposed to be 6L6s, but somebody else had 5881s, so we went with that. New bias electrolytic and resistors. New screen grid resistors, the other ones were toast. New grid stoppers, because the other ones were toast. Redid the filament wires here because they were backwards on the first two sockets, so we fixed them to reduce some hum. We put a chassis ground all around this transformer. We got rid of all the grounds to these lugs that just don't last and screw things up. So chassis ground, new chassis ground there, chassis ground there, and a chassis ground there, 3-prong cord. And then one mod is we've got the ground switch turned into a negative feedback off and on switch, which sounds killer. Cleaned all the pots and jacks and everything and switches, because they need a little cleaning too, and everything sounds pretty good now. And then all new electrolytics in the doghouse as well, F&Ts, and all new resistors in the doghouse. I needed them too. They're all the power resistors, and they're pretty much toast. So there she is, one last flyby. Should be good till some resistors go out, or any of these blue caps, which not leaking DC at the moment, so leaving them out. So we had to go back in and redo this tremolo, and we ended up putting a new LDR in, as well as 0.032, 0.02, and 0.01 caps on the right, and on the left a 0.01 across the LDR, and that got rid of the tick and got all of our gain and volume and everything back. We got rid of all that other stuff we had in there, which was a fix, but this is better. Also, the 0.032, 0.02, 0.01 caps make it real slow and real syrupy, nice tremolo. Factory is 0.01, 0.01, 0.02, but it's just really not slow enough for me anyway, or the other tremolo hounds out there. Alright, one last look in here. I think I finally got this tremolo circuit to quit ticking. So we replaced that LDR. We ended up putting a 0.02 across from the 10 meg over to ground there. We put in a new 10 meg resistor. The original carbon comp one had risen up to 12 megs. Then I put in a metal oxide resistor, and the ticking came back. So now I put in a carbon film, 1/2 watt, 10 meg. I couldn't find a 1 watt, but it's only supposed to be a 1/2 watt resistor anyway, so it should be fine. Everything sounds good now. We also moved this capacitor over away from the LDR a little further and put the resistor closer. Don't know if that made any difference or not, but I think we got the tick out. Everything is finally done and sounds awesome. a new switch you have that you didn't have before. Back here, your old ground switch, and I labeled it too, is now a negative feedback switch. And here is original position with a negative feedback on, which basically makes it quieter and cleaner. Flip it over, it's got a lot more grind to it. Basically, it's not going to be, you'll hear it in a minute. It makes a big difference, especially at lower volumes. A few things you don't, what you know about your master volume. I put a label there. It says master volume now.
Yeah. How is that for going? This glue or tape?
It's a label maker. Tapes. If you really want it off, it'll come right off.
Yeah. Do you have it here? Base pick?
I left out a base pick for you. You can have this. This is a real foot switch for your vibrato. If it ever doesn't work, spin this. Sometimes the ground doesn't connect. Or you can go without foot switch, and you can have this. This is just a dummy plug, which does the same thing as a foot switch, and just plugs in there.
So at this point, it really shouldn't electrocute anybody messing with any of it.
No,
Right?
it's all been. It has a 3-prong cord on it now. The depth capacitor is out of circuit. It's gone. It's
Rusty player sound something half bad.